Hi there, let's go over your answers to topic 3 in the textbook, which is on pages 197 and 211. Characteristics of acid versus base. So the first characteristic, which is silly, but it's taste. It's silly because you shouldn't taste an acid or a base. So an acid tastes sour and a base tastes bitter and feels slippery. The other thing about these is what they do to litmus paper, which we'll get into later. Some other things, when you look at the pH scale, pH is 7 versus 6 versus 8. What that really stands for is the hydrogen ion concentration. So a pH of 7 is 1.0 times 10 to the negative 7 for hydrogen ion. And this is 1.0 times 10 to the negative 8. And this is 1.0 times 10 to the negative 6. So that's what pH scale is based on, is the amount of the hydrogen ion. Let's do the next question. What's an indicator? An indicator is a substance that changes color in the presence of an acid or base. Often plant products make good indicators, and so that's how we make pH paper. So pH paper turns different colors. Let's keep going. What is litmus paper, and what color is litmus paper in a base, and what color is it in an acid? So litmus paper is another kind of indicator, which, as I talked about before, it's a plant compound made from lichens. Remember lichens? Lichens were tiny organisms used to break down rock. So pH paper turns red in the presence of an acid and turns blue in the presence of base. So if you take some paper, here's my pH paper, and maybe this is red litmus. If I dip this red litmus paper in a base, it turns blue. If I dip this red litmus paper in an acid, it stays red. What is the pH scale? It's a way of comparing the relative acidity or alkalinity of a substance. Less than 7 is an acid and greater than 7 is a base. And again, we know a little more than that. Mathematically, I talked about this. If something goes from a pH of 5 up to a pH of 6, it has jumped a factor of less than 10. Okay, in other words, what is this? This is 1.0 times 10 to the negative 5. If we go to pH 6, that's 1.0 times 10 to the negative 6. So we've divided by 10. This is basically 10 times smaller. If we go this way, pH of 4 is 1.0 times 10 to the negative 4, so we went up by 10. Next, what is a universal indicator? An example, pH paper. It's a substance that changes color that's characteristic of a specific pH. So litmus paper isn't as useful because it only turns red or blue. Okay, that's a bit of a problem with litmus paper. However, pH paper is more useful because it will change all sorts of different colors depending on what you have. So pH paper could turn a really dark red, it could turn kind of an orange, it could turn yellow, green, and blue, okay, depending. So red would be really strong acid, orange, weaker acids, yellow, getting close to neutral, green, a mild or a weak base, and then blue means a stronger base. So that's much more useful than litmus paper. We'll come back to this after in part 2. Also, this wasn't, so let's skip this. Number 5 actually on your worksheet says a pH of 4 to 6. We'll go over that in part 2 because I'm out of time. See you soon.